Good morning, October 22nd, 2016. Today's presentation, the electrical interaction between the sun and the brown dwarf, part 2 of Physicist Thoughts. Let's begin. In the first of these articles, I looked at what was happening between the sun and the brown dwarf in 2007 and January of 2008. Figure 1 below shows an electrical interaction event during which a current flows between the sun and the brown dwarf. This event, which I would like to call a plasma glow event, happened on January 3rd, 2008. I showed in that document that the space between the two objects had filled up with ionized iron, which is essentially plasma, which can therefore conduct electricity, and will do so once the electrical potential between the two objects reaches a critical level. So on January 3rd, 2008, there must have been a large enough electrical potential difference between the two objects for an explosive plasma glow event to happen. Notice as well that the energy collector device was not present during the explosive plasma glow event. Thus, the energy collector cannot be a determining factor in the occurrence of these explosive plasma glow events. What we are referring to is this enormous event that's taken place here. Figure 1, H12, SRAM A images is provided by Sechi from January 3rd, 2008 at 10:17 and 12:09 UTC. The region of space between the sun and the brown dwarf goes through a plasma glow event. Figure 2 below shows that the brown dwarf in its usual position in front of the baffle and the space between it and the sun on September 1st and September 8th, 2016. Venus and the energy collector device also appear in these images. A line of ionized iron runs diagonally upwards from behind the baffle at the top of the image, indicated by the red arrows. We're going to see this below. Then some of the ionized iron runs vertically downwards towards the bottom of the image. There is also what seems to be an object at the top and another at the bottom of the vertical line, which will be indicated by the purple arrows. Iron oxide does not align itself in a straight line unless it is compelled to do so by an electrical field, which further suggests that there are charged objects, indicated by the purple arrows again, at the top and the bottom of both images in Figure 2. These objects then act like electrodes, setting up an electrical field along a vertical line joining them. The rest of the ionized iron ends up accumulating close to the sun, as seen as two white regions at the left of the image, which is indicated now by the yellow arrows. In the right image, we also see what some of the ionized iron seems to be directly interacting with the parabolic part of the energy collector, indicated by the blue arrow. The long lines of ionized iron are essentially currents, so what we have is a current running through the solar system from the brown dwarf to the object at the bottom of the image, at the top of the image, and from where the current splits. Some goes vertically down to the object at the bottom of the image, and some goes to the sun. This means that the solar system is now an electrical circuit with ionized iron as wiring. Okay, there's the diagonal line. The charged objects are with purple, right? The accumulation of ionized iron right here. That's so weird looking. And of course, the energy collector with the parabolic lens on it. It appears to have two different functions. Figure 2, H12 SREM A images is provided by SETI from September 1st, 2016 at 2:09 and September 8th, 2016 at 16:09 UTC. The white lines are made of ionized iron, suggesting that the solar system has turned into an electric. Figure 6, H12 SREM A images is provided by SETI from September 20th, 2016 at 20:09 UTC and from September 27th at 18:09 UTC. Plasma glow or discharge events between the sun and the brown dwarf are seen in both images. Look at that. That's huge. Figure 7. H12 SREM A images is provided by SETI from January 3rd at 12:09 on the left and September 27th, 2016 at 18:09, showing powerful plasma glow or discharge events between the sun and the brown dwarf. The right image is the same as the left image, rotated by 180 degrees. The plasma glow events seem to be a bit more powerful than the ones happening in January 2008 and shown in Figure 1. The September 27th plasma glow event seems to have two layers, a large dark layer going to a point behind the brown dwarf and a white layer over it that does not seem to reach the brown dwarf at all. The left image in Figure 7 below shows one of the plasma glow events in January of 2008. The central image shows the September 27th, 2016 event, and the right image is the same as the left image but rotated by 180 degrees so that the sun and the brown dwarf orientations are the same as in the September 2016 event. There's a lot of similarities between both events. There is a dark discharge and a white discharge. If we compare the central image with the rotated right image, we see that the orientation of the white discharge is downwards in both events. There's that device again, too. Why is that thing there? Figure 8. SREM A images as provided by SETI from September 22nd, 2016 at 2:09, 4:09, 6:09, 8:09, and September 23rd, 2016 at 20:09 and 22:09. Figure 8 shows that the electrical interaction between the sun and the brown dwarf becomes very active on September 22nd. September 23rd. The top left image shows the plasma glow event that occurs at 2:09. At 4:09, the plasma glow event decreases in size to cover only half of the image, upper middle image, where the line of ionized iron running vertically downwards is located. Okay. This suggests that the line is acting as an electrode. The object at the top left of the ionized iron line must be a higher potential than the object at the bottom, because charge flows from a higher potential point to a low potential point. But both points must be a lower potential than the sun in order for a discharge to occur between the sun and the line of ionized iron. The discharge is the sun's attempt to equalize the potential between itself and the point where the discharge ends. Notice that this discharge does not dissipate but continues until September 23rd at 22:09. This suggests that the sun is kept trying to equalize the potential between itself and the vertical line, but as fast as the charge was delivered to the line, it must have flowed elsewhere, either to the stars at the top and bottom of the line or the energy collector device seen in the images, or perhaps both. So several objects must have been charging themselves through the sun's plasma discharge. Figure 9. I mean, it's huge. This thing's huge. Look at it. I mean, come on. It's so obvious. Look at this. Figure 9, H12 SREM A images is provided by SETI from September 25th, 2016, 2:09, 16:09, 18:09, 20:09, and 22:09, at September 26, 2016 at 2:09. Showing various plasma discharges from the sun to the brown dwarf, or the line running vertically between the top and the bottom of the images. Okay, now figure 9 shows that the discharge between the sun and the vertical line of ionized iron continues until September 25th at 22:09. On September 26th at 2:09 in the lower right image, it finally disappears. On September 25th at 18:09 and 20:09, top right and lower left images, we see that there is a plasma glow event between the sun and the brown dwarf that seems to have occurred behind the discharge between the sun and the vertical line of ionized iron. This discharge first looks black, indicating that protons are being emitted from the region, and then white 2 hours later, indicating that heavy ions were being emitted from the same region. This happens because the plasma glow event heats up particles in the plasma so that they move faster and collide a lot more, and also go to higher energy states. So as a result, many more particles leave that region of the discharge in the direction of stereo A's SREM detectors. And since protons are lighter than iron ions, it makes sense that if protons are present in the region, that they would arrive at the SREM detectors first. Protons come from the solar wind and will therefore most likely be present in the region between the sun and the brown dwarf. Now, since the discharge on September 25th at 18:09 and 20:09, which is in the top right and lower left images, seems to occur behind the discharge between the sun and the vertical line of ionized iron, which suggests that the brown dwarf is in a position behind the line of ionized iron. In other words, the vertical line of ionized iron is closer to stereo A's cameras than the brown dwarf. Figure 10, H12 SRAM A images is provided by SETI from September 26, 2016 at 2:09 and 4:09, and September 27, 2016 at 8:09, which are showing plasma discharges from the sun in the form of wave fronts. That's what that is. Ending at the line running vertically between the top and the bottom of the images. That is so obvious. Wow! Great job. On September 26th at 2:09 and 4:09, and September 27th at 8:09, we see another type of interaction between the sun and the line of ionized iron, as shown in Figure 10. This discharge is not a solid event affecting the whole region, but it seems to occur as wave fronts that are flowing outwards from the sun. In conclusion, the analysis of the electrical interaction between the sun and the brown dwarf during September 2016 reveals that the electrical interaction is extremely active, and that the sun is also interacting electrically. EMP comes to mind. With the line of ionized iron running vertically between the top and bottom of the images, these interactions were already occurring in 2007 and at the beginning of 2008, but they were not as numerous or happening as often. Also, there was no sign of the sun interacting with the vertical line of ionized iron. This suggests that the amount of plasma in our solar system has increased dramatically. This plasma would be mainly due to the increasing amounts of ionized iron ejected by the brown dwarf. A Physicist's Thoughts, October 22nd, 2016. Have a great day, take care, and have a good one. Bye now.